Hello and welcome to another visual coding video. My name is Robin Palmer, and today I want to continue with our sessions on data visualization using processing. And in particular, I'm going to build a COVID-19 tracker using live data that's available on the internet. So I do want to just issue a warning to any of you. I'm not going to deal with any sensitive subjects other than the mortality rates globally from this virus. So if that is anything that might trigger you, please just be warned of that in advance. I think for the rest, it is a very interesting and, of course, completely topical subject to look at. And I think, data visualization is all about dealing with important data and trying to make it relevant. So I thought that this would be worth delving into a little bit here. To begin with, I'd like to provide some structure for what we're doing by reviewing the 6 data visualization steps, which are apparent in any data visualization process, or they should be. You should be thinking explicitly about this. Some are a little bit easier than others to come to grips with. But these are the 6 steps. Now, these don't occur just in a linear order. It's an iterative process, like any design process, to create a visualization. But the first step is to acquire our data and find a useful, pertinent, and available data source, which can be quite a challenge. The second step is then to filter out that data for the essential components that we want to use, to get rid of the noise, fields that are meaningless to us, to parse the data into a useful format. That's all quite important. The third thing then is to find patterns in the data. So once we have the data and have boiled it down and constrained it to what's relevant, it's still it can be quite a challenging task to find the relevant patterns for what we want to say about the data. We choose a visual model to represent this. Now, this is also there's quite a bit of aesthetic choice here, although quite often there are just better representations for different sorts of data. So if you have one independent variable, you could have like a bar chart. If you have 2 independent variables, you might want something else. Some of the old standbys, like pie charts, are really quite poor choices to represent any sort of complex data. Mapping, in terms of putting your data on a geographical map, is what we're going to be looking at today. And it can, of course, be very useful if your data is geographical. So step 5 then says map. And we're not talking about geographical maps here. We're talking about the mapping function, the transformation of this data structure that we have developed to the visual representation. So how are we going to do that? Which factors in the data are going to be represented how? With shapes, with sizes, with colors, with form, with, there's all sorts of different visual parameters that we can use. So I would say that this is a very difficult part of the visualization process, is the mapping. And finally, we wish to have some interactivity. We are, after all, using a visual interactive coding tool. We want the viewer's input to matter. Certainly, we could present static data, and if you're producing graphs for newspapers or magazines and so on, websites, you might do this. But more and more, and many of the examples I would show you, they are interactive. And the reason for this is that the viewer can choose how much detail to look at, how specific to get. They can drill down to particulars that they are interested in. This is very important, especially when dealing with very large data sets. So this 6-step process then is one that you should always have in mind and be thinking about as you work through your coding. And of course, it makes good sense to plan this ahead of time and to provide some planning documents and some structure so that you don't get lost in the coding itself. So you always know why you're writing that method, why you're writing that class, what does it have to do in the big picture. Okay, so this is our 6-step process. So I began with this webpage. This is the Johns Hopkins University COVID-19 dashboard, and it represents current data that's being updated continuously on the virus outbreak around the world, and it represents the data using these red circles on a map. So they have chosen this particular graphical representation, which makes a lot of sense. They also have charts to the side, the total confirmed cases, the deaths, and the total tested in the US, because they are a US-based institution, and this is of particular interest to them as a hospital. So they've made certain choices about what to represent here, and for which geographical regions. But there was a couple things I noted about this that I didn't like. First of all, I find the map scary. The map's a little bit scary because they've chosen a dark background and these red circles that are quite intense. And also you can see how the circles really just cover everything because of the scaling that they've chosen. So that's one thing, is the sort of emotional impact of this map. Perhaps it was a deliberate choice, but it's something that I might want to mitigate a little bit in my own representation. Secondly, I'm not sure why we need to see Antarctica here as this giant landmass and so on. So the map that they've actually chosen is not necessarily the best. But the next thing I noticed, maybe my third criticism, is that if you hover over, you don't really get anything. You have to click, and then a panel comes up showing you just a bit of basic information. So the country, the confirmed cases, and the deaths. That's not necessary. I mean, people are going to try clicking and so on, so people will discover that. It's not like a big problem. But just note something about this. So 10,612, which is quite a large figure for the United Kingdom. Ireland, 334. Okay, 334, a third of 1,000. 10,000, more than 10,000. So 32 times more deaths. Does that circle look 32 times worse than that circle? I think the answer is no. So I don't think they've chosen a very good mapping here, because it's distorting, to me, my interpretation of the data. I look at this and I think, wow, that's a lot in Ireland, especially, Ireland doesn't have the same population as England. Wow, things are really dire, and it's just not true. So these circles do not accurately represent the sort of differences in the raw numbers. And that is a problem often with visualizations, is sometimes the visualization is chosen for other reasons and not because of the accuracy of the representation. I would consider that quite a flaw here. Now, of course, in the time that we have today, I want to create, in processing, a similar display, much simpler. We won't bother with all the data tables or the graph at the side. It will just be a map. It will not be zoomable. I'm going to do things in a simple way using fairly basic programming tools that hopefully at this point you already know. And nonetheless, I think it would be a great starting point for something more developed. So that's the task ahead of us today. So I found on GitHub this coronavirus tracker API, and it gets data from two sources, which turn out to be two of the sources used on the previous dashboard. So it's the data itself should be quite compatible. So the first source, which is the default when you use this API, is worldwide data from Johns Hopkins. And the second source is the US county data that comes from a different place entirely. So I thought there's no point drilling down into the counties necessarily. Let's just stick with this data source. So if you read on here, it will tell you something about, it's actually a little confusing, but it will tell you something about how to access the data and the format that it comes in, which looks like this. How about I take a look at that now? If I access this directly by pasting in the URL, that's what it looks like. So that came back very quickly, and it's a huge mass of data. Okay, so let me copy that. and paste it into a file. Okay, and when I do that and just tidy it up very, very slightly, just in terms of some line breaks here, this is what I get. So we can see that the top level, there's an open brace at the very top. So the top level is what's called a JSON object, and it has two entries, latest, which just summarizes the latest data, and locations. And within locations, we have a square bracket, so we have a JSON array, and that goes all the way down for every country to the end. So that's our basic, our top level. So we're going to want to access a JSON object, grab out locations from that, and then within that, it's an array, so we can iterate over each of these entries. For a given entry, we have the country, the code, the population, province, which is often blank. But when you get to countries like Canada, it turns out that individual provinces are indeed specified here. Same with China and a few other larger countries, which is useful. Last updated coordinates. So coordinates we'll want the latitude and longitude. And then if I scroll to the right here, and then under latest, there are confirmed cases, deaths, and recovered. But you will notice that recovered is always 0 because they've actually removed that information from this feed. I don't know why. I think just because the accuracy of it may have been too suspect, and they didn't want to promulgate that information if it wasn't accurate. Okay, so this is the data. Now, what I always do when I'm going to be building a program that accesses any live data on the internet is I grab a test sample. And I've done that already. I can actually close this as a result. I've done that already. Here it is in my file. And so I'm going to place that in a convenient place for my project to access. And that way, when I'm writing my code and testing and debugging, I can work off this data set without constantly making requests over the internet. In this case, that may not be a big problem, but in other cases, you might have restrictions on how often you can access the data, and you don't want to abuse any of the rules or terms that you have agreed to with whoever is providing the data for you. So let me just close this up then. Minimize this for now. So I have a folder here, COVID-19, and within it I have this sample file, which is empty right now. And I'm just going to make sure that I have the data in here as well. Just copy that file into the folder. What I like to do is I like to make a subfolder for all of that. In this case, I'll just call it data. Throw that in there. Processing will be clever enough to look in there for anything that I need. So while I'm thinking of stuff that I need a map. What I did was I went looking first on Wikipedia and then on some map sites. And to be honest, I found it really hard to find a suitable map because I wanted one like this that had the country borders, but which was relatively plain and unassuming so that when I can easily overlay data on top of it. Is this Finnish or Swedish or something? This isn't even the English version of Wikipedia or Wikimedia that I found this on. Anyway, this was the nicest one I found, but it does have a few weird things like lines in the middle of the ocean and a lot of dots for a lot of places that may or may not correspond to data that we have. So I took this, I cleaned it up a little bit by getting rid of some of the excess detail, and I resized it to something appropriate. And then I crossed my fingers that it was going to be the right type of map for the data that I'm receiving. And the reason is that mapping is an extraordinary complex enterprise. This is a Mercator projection. There are different types of Mercator projections. The common ones that are used, say, for Google or Bing or Open Maps are actually not very accurate geographically. They use a very sort of strange hybrid sort of mapping of global data because, of course, we're trying to represent a sphere on a plane here. And so you have always compromises in doing that. You're either going to distort linear distances, coastlines, areas, or something else. This projection incredibly distorts area. And it's one that we're quite used to looking at. So if you're at all interested in maps, you should read up on that. It's actually quite fascinating. Like Greenland is not this gigantic thing like that, and neither is Antarctica. Whereas Africa is actually bigger than a lot of the rest of this put together. It's much bigger than it looks even here in terms of its area. So this is a distortion, but then all planar maps that fill the surface at least are distortions. They have to be. It's just a matter of compromise. Okay, so this is going to come back to haunt us later on, unfortunately, but this was the best map I could find. OpenStreetMaps have their own wiki, and I found in here some information. It's like all super technical stuff here. So basically, this is how you convert from longitude and latitude to X and Y coordinates using this projection. So these are the equations that I'm going to implement, but you will be happy to hear that they can be much simplified from what you're looking at. All of this 2 to the power z is just about scaling for when you're zooming in, and we're not going to be doing any of that in our simple example, so all of that disappears. And some of the rest of this stuff, like latitude times pi over 180, that's just a conversion from degrees to radians, so that will disappear. Yeah, it will look a lot simpler than this, but this is where I got this information. So we're still in the data gathering and research stage of our visualization at this point. So first of all, I'm going to set up the main part of my program, and as usual, I like to define a bunch of color constants. And the specific one that we have interest in here is our red. So what I'm going to do is, I've got white and black and a sort of a gray scale that's mostly white. It's a light gray. I have red that I'm going to make transparent so that, say I've got different red circles overlapping. If I make them quite transparent, then I'll be able to see all of them. Now, I mentioned that I've got data locally. So how about I set up a flag for that so that I know when I'm using local data. So I'll call it local, true for now. I'll use the local data. And then I'm going to need an image for my map, a couple typefaces. I know I'm going to need a couple fonts, that is. So, yeah, whoops, map. So this will do for now. Let me write a setup routine. Now my image is 1200 by something, 700 or 600 and something pixels, it turns out. So I'm going to size my canvas to 1200, but then I'm going to provide extra space below the image that I can use as an area for displaying some information. Okay, so I'm just going to write the real obvious stuff here. First of all, I'll put in my typefaces. F, create font. I'm going to use this font at 14 points, and then a bold version, which I'll call double F, kind of double forte, using musical notation here, just because forte and font both start with F. So my bold is bigger and bolder, and I'm going to make sure that's left aligned. I think it is by default. And then I need to load in my map as well that I'm using. Load image, map.ping, load image. Then I'll need something to handle my data here. So handle data. That will take quite a bit of thinking about. Whoops, 2 E's there. And then our draw routine. Set the background to white. Put our image up there, our map at 0, 0. And then I'm going to draw a panel. I'm actually going to set up a separate function for that because it could get quite complicated what I want to draw. Not complicated, you know, but just kind of fiddly. So, and then I'm going to render the places, all the red dots as red circles. That will happen once I have my data. Right? So, yeah, I'm just working through this. And then I need something to handle interactivity. So handle mouse pointer. I'll just put that there as a placeholder so I know I need to do that. Right, just for a second, let me go back to this folder and make sure I have everything that I need, which I don't. I actually need my typefaces, so I'll copy those in there. That's a free typeface that I'm free to distribute, by the way. And the map. That needs to go in there too, the ping file. Right, that's all the resources that I need then. That's all I'll need. So now I'll just work away on the processing file itself. What I'm going to do is, rather than type out every line, I'm just going to copy and paste some things that might help us out here a bit. Okay, so this is going to have a gray background, and the rectangle is going to start at 0 x coordinate, but below the map. So the map height is going to be the y coordinate. It's going to be as wide as the map. And the height will be whatever is left on our screen. So the total height of our canvas, take away the height of the map, and that is the height of the rectangle at the bottom. And then I'm going to draw on that in black text. I'm going to put a heading here at position 20 and give it a bit of a margin there away from the map, 40 pixels. Set the font to our bold font and put that on the screen. And then I'm going to move a bit to the right using this interesting notation here, which uses text width. So the reason I formed a string of our text is so that I could actually simply use text width to figure out how many pixels wide that is. So processing can do this for us because it knows the font and it can use the built-in font information inside that file, and it knows the letters and symbols that we're going to print. So it figures out the width. I'm going to add a margin of 10, switch to my normal font, and print out now. And now is a timestamp. So I had better define that. Well, first of all, I better actually define it up here, string. So this is going to be the time at which we've grabbed the data, and we put that on the screen just so we know how fresh the information is. That makes sense to do. There are various functions available: year, month, day, in processing. And the easiest way to combine these into some sort of a string is to use string format. And this uses a notation that is the same in C and so many other languages. It uses the printf or the sprintf notation, which is a little bit obscure, and it's worth getting a reference for this online when you go to use it. It's not described in the processing documentation at all that I know of, but it is a standard notation. So what we do is we have a string that is our format string that describes what we want to output, and then we have various parameters or variables that we can fill in, like the current year, the current month, the current day. These are numerical attributes here. And that format like that. So that is valid syntax now, although it won't print anything because we have an empty string. So what we should do instead is format year. So year comes to us as an integer, and the symbol for integer is %d. Then I'm going to put a period, and then another %d, and then a period, and another %d. So each of these % things is a variable that will be filled in from the data here in order. So that's actually enough for this to work. It's not exactly what I want. I know that right now. It's enough for it to work. So perhaps we should, you're not going to define now in our draw loop. That was incorrect. So I don't see any errors here. Let's just run this and see what it looks like. Wow. Yeah, we've already done a lot. There's our map. Here's our panel at the bottom. You can see we're using different typefaces, and it says 2024-12. So that's the date. And I'm using ANSI notation, year, month, day, because that's the most unambiguous. Otherwise, people viewing this from North America, other parts of the world, and the English-speaking parts of Europe will expect month and day and everything in different orders. It's so confusing when you see dates. One thing about the 4, the April, is it should really be padded with a 0. So it's 2020-04-12. That would be the actual best way to do it. So that means knowing a little bit more about our notation here. And it turns out if you want 0 padding in front of a number, you just put a 0 in front of the D in this case for decimal, which is what we use for integers. We use F for floating point, S for string, and others. Those are the main 3 though. So yeah, so please do look this up, and if you want the printf function, printf is the quickest way of looking up this information. Well, if you've watched any of my other videos, you know that I like to do things in a very organized fashion. I like to use object-oriented programming wherever possible. This is no exception. So I'm going to start a new tab for some classes that are going and functions that are going to handle our locations. So we're going to need a couple of things in here, a couple of different classes, and I'll just put in the framework here. We're going to need a class called location. Which will handle all the information for one of our points, one of our places on the map. And then we're going to have a class locations, plural, which will have an array of these locations, just so that we can easily work on them as a group. This is such a standard way of organizing data that I just do it sort of instinctively. So what do we need in each location? Well, it has a position. The circle also has a certain size. So we can start with that. So I'm going to use floating point just because if we have to do any calculations, it will be easier. So let's x, y, and radius for our circle. And then we've got different textual information. We have the country. We have the province. Now this I know because of my data set. We have a label that we might want to associate with that. This should say province, not prince. We have a population. I guess that's an integer. We can change some of these if we need to. And we have a number of cases. These could be, I'm going to make these floats as well. If ever I think I need to do any maths with anything, I always make something a float. So it just makes it easier later on. I can always change it back to integer if integer is good enough. I'm going to want to form a label or a caption, whatever you want to call it. And that's going to return a string for sure. I can actually make sure that this is sort of set up for that. Whoops, that's the wrong symbol. There we go. Now it matches. Now we have a return type result. May not have been initialized. Well, you're right. Okay. Just to stop it nagging me, I'll do this. Yes, and then I also need to be able to render this place, and I need to check the mouse hover. I'll call it hover then. Is the mouse hovering over this? And if so, then I can actually print out this label, do something like that. Now, considering locations, we know that we're going to have an array list of type, of individual type location. Whoops, that better match the casing correctly. I'll give it a name, and I can initialize it to start with. Yeah, like that. So when I start this off, when I kick off all my locations, the first thing I'm going to want to do is retrieve and parse the data. And I get the data from two different places depending on the state of things. So let me define an URL, and then I can check my flag that I set up. So if it's set up to be local, then the URL is going to be taken from one place, and otherwise the URL is going to be taken from somewhere else. And the somewhere else we've already seen because I accessed it directly in Chrome a second ago. That is this address. And the local data is in here, and it's called COVID. So I can just put that in here. And we don't need a path for our data folder because processing will find that for us. Okay, so this specifies the URL, and then we can parse our data from that URL. I'm going to set up a separate function for that because I like to have a separate function for everything, for every different action. That way, if I need to reparse the data, I can do that. Okay, so parsing the data. Well, let's have a look at it again. So we need to use a succession of JSON object and JSON array calls. And at the top level, it's pretty simple. We want to access our URL as a JSON object because of this first parenthesis. So let's do that. And then we are interested in the locations field within that, which is a JSON array. So JSON object data will be given by load JSON object specifying the URL. And then once we have data here, we can within that get a JSON array called locations, and we'll return that to a JSON array. And then everything we do from here on out will be in that array. Now, unfortunately, there's no object notation here for cycling through the array. I wish there was, but we have to access the array objects themselves using an integer subscript. So I have to write the good old-fashioned for loop and not use the object notation, which kind of sucks. So loop over the total size of locations, like so. And then for each item here, we want to get a JSON object, and that will give us our place entry. And then we can quickly extract the country, which is a string, and the province also, which is a string. It's empty in many cases, as I mentioned before. So let's do that next stage, like so. Whoops, I'm missing the JSON object statement. I'm going to just paste that in here. Save me typing and making errors. So there, we're going to get a JSON object for each index from locations. That gives us what I'll call a place. And on place, we can get the country string into country. We can get the province string into province, although it might be empty some of the time. And we can go ahead and grab the population as well. So that's an integer. So we'll grab that out of place and then have a look at the data to see where we go next. Next we have coordinates, and coordinates is another object there. It's got more squirrely brackets, so we need to get it as a JSON object. And once we've done that, we can extract the data within it that we want, which will look like this. JSON object coordinates, get JSON object on place, and then once we have coordinates, we can extract latitude and longitude, which are strings, but I obviously don't want them to be strings, so I'll convert them to floating point values. And likewise for the latest data, which is the confirmed cases, the deaths, and the recovered, but we won't take the recovered since the data is absent now. So that looks like this. And in these cases, we get them as integers, and they come out as integers, which is nice. And that gives us all the data that we need. So we can now add all of this to our array as a new location. Like so, country, province, latitude, longitude, population, cases, and deaths. That forms a new location. That tells us right away how we need our location constructor to work. So what I can do is copy all of these here. Here's location, here's our constructor. Paste those in. Now I need to make sure that they are defined as parameters of the correct type. And I'm going to use my little trick. I'll just put an underscore after them to change them to a different variable, but one that looks familiar. Latitude and longitude are floats, are they? Yes. Population is an integer. I have to remember all these things. Cases and deaths, I can see them above on the screen. They're both integers. Right. Okay, a very long list of parameters that we send. And then equally long, we're going to need to save each of these. There we go. Save each of those to the properties of this class. Now that we have all that information, we can create our label, which is form label. So we can call this to create our label that will go on the screen. And we can now convert to X and Y from geographic coordinates. We can do that to get our X and Y. Geo to our map coordinates. We're going to give it the latitude and the longitude, quite naturally. And what we're going to get back are X and Y. We want to get back two values, so that's like a floating point array. Set it up like this. And then our X is going to be the first value of that, and our Y will be the second value of that. Okay, so let's write this. Whoops, not yemp. So let's write this geo to map right now. I'm going to copy this so that I know sort of what it's supposed to be like. So it's got to return a float array like so. And what's it going to do? Well, I showed you the math a moment ago. First, we need to convert our latitude to, doesn't matter what I call these, I won't do the underscore thing here, just save myself some typing. Latitude is radians. And then the math for latitude is very simple and very easy to understand, because latitude goes from minus 180 degrees all the way up through Greenwich median at 0 to plus 180. So as I type, I'm in about minus 8 degrees latitude in this part of Ireland. So in order to convert that to some sort of scalar value, oh yeah, what are these values going to be? Float x and y. So what I want to get out of this for our map is where on the map these points live. So I want to float between 0 and 1, and that way I can scale them to whatever size the map might be. Like I said, the first part I think is easy, because if we take our longitude and add 180, because we start at minus 180, right? Let's get rid of negatives first. So instead of minus 180 to 180, we are now going from 0 to 360. Let's keep it all floats. And then if I divide by 360, I'm actually going from 0 to 1, and that is the scale that I want to be on. So if I flip back to the maths page, you can see here that's actually what's going on here. You add 180 and divide by 360. Again, this 2 to the power factor, that's to do with zooming. Forget about that factor. So the x is really easy to understand. The y equation, what the heck is all of this? Latitude times pi over 180, we already handled that by converting to radians. But nonetheless, we have quite a complex setup here with different trigonometric functions. And the reason is that the Mercator projection is kind of a strange combination of more than one mathematical transform. Now, if I transcribe this equation to Java or processing, this is what I get. Not the hardest thing in the world to read. We have a cosine, we have a tangent, we have log, which is actually a natural logarithm in processing, and we have some, pluses and divides with the numeric constant pi. You can take that on faith if maths is not your thing. And now we're going to return a float like this, an array of two floats. So we're going to create a new array, and the values are going to be, x and y. So this may be new to you, this kind of notation, but it's just how you do an array, a return value for an array. Right, so we give this function two values, and we get back two values, and when we get them back, we do have a temporary float here, but then we extract the two values, the x and y, and remember again that is a scale from 0 to 1. So the x we need to scale by the width of the map, which will give us a position from left to right on the map, and similarly we use the y for the height of the map. Let me just run this to make sure that there are no issues. Maybe missing a semicolon. Yep, I'm missing a semicolon. Thank you. Thank you for your helpful error messages. Maybe missing something else here. Oh yeah, that's just a bad typo as well. Best to clear all these up. Expected token lat. Oh yeah, we haven't described what these are. They were floats. It's really good to run and check all your syntax errors regularly, and that way they don't accumulate and get too confusing. There we go. It likes that. No more errors. Okay. So I think the best place to start is with the render. We actually want to plot these circles according to the mortality rates in the different regions. And so to do so, in order for the values to have some bearing on what we're plotting, in order for the visualization to be accurate, we need to decide how we're going to do this. Now, the most obvious way would be to scale our radius according to some sort of a fraction. So we could say take take the mortality in this region and divide it by, say, the maximum mortality, which we don't have any record of yet. And then we could scale that to be a radius. But it actually makes more visual sense to instead use the area of the circle. So instead of the radius, I'm going to scale according to the circle area. And this is actually really, really simple. I mean, we know the equation is pi r squared, but we don't really care about pi. I mean, that's just a factor in there. And we're going to want to change our factor anyway to get the circle sort of the right number of pixels. So the important part is pi r squared, the r squared. So if we go from area back to radius, we want to take the square root. So if we take the square root of this fraction, then that will give us a number that we can then multiply by a certain number of pixels. I have no idea how many. I could start with, say, 100 pixels times this, which will be a fraction. So everything will be below 100. The most this could ever be is max over max, which is 1. Square root of 1 is 1 times 100. So actually, that's quite a lot. A radius of 100 is quite a lot. Maybe that's too big, but we'll leave it at that for now. But in some cases, if the mortality is really low, this is going to be like a super low number as well. Okay, so then we can fill with red once we have that value, and we can draw a circle using our known values for this location. So max depth, what is that? Well, yeah, we're going to need to know what that is. It better be a float as well, since we're doing some division here. So let's pass that to this render, and then work our way up to see how that's going to work. So this is the render for one individual location, but really we want to render them all together up here. So that's something I didn't do. I didn't fill in the fact that we're going to need a render here as well. And this is going to do our rendering for everything, you know. That's why we have this top level locations class, is so that it can handle, you know, it can handle all the individual things for us. And in this case, we can do a nice loop using our object notation. So for type location variable L in all our locations, we can do something with L, and we'll render it passing this parameter because we set it up to receive that parameter below right here in this line, float. So that's all we need. So this renders all locations. Renders all location circles whenever we call it. So yeah, so how are we going to get this number? Max depth is still like an issue here. I guess when we're parsing, we're going to need to keep track of this. We're going to need to figure out what's the maximum number in any one place so that we can scale all our circles. And we define it to be a really small value, like 0, the smallest possible value. Then every time we go through this loop, we can see what we have. So our new value will then, what is it? It's deaths here. So there, we don't even need a conditional. Whoops, I have an extra parenthesis for no good reason. I think this is the simplest way to do it. So each time through, we compare our previous maximum with the current deaths, and if the deaths is greater, it's our new maximum. I definitely want to see some of this in action. So in order to do so, we need to set up our, let's go all the way to the top. We can set up an instance of locations called places. Why not? And then in here, handle data, sure. We can create a new instance. And as we know, that will also kick off the parser, because the parser happens right at the beginning. So this will do all our parsing for us. So once this is complete, we are ready to roll. So render then will be places dot render. That's all we need. That should do our rendering. Let's see. Let's see if this works. Nope. Runtime exception. JSON object. Country population is not an int. Well, this is very curious. Let's have a look at our data again. Country population. Sure looks like an integer. Sure looks like an integer. Wow, this is weird. So one would have to inspect the data. Sort of item by item. Oh, wow, look. Country population null. That's interesting. The country is MS Zandam? The MS Zandam? What? Oh, that might be a ship. Oh, of course. Ships might be included in this. Right. So it has no country code either. Ah. So this data, I would have to say, is ill-formed. If country population is supposed to be an integer, null is not an integer. They should have used 0 or -1 or something that at least would have been valid, but they used null. Whoops. Well, how are we going to handle that? That's really annoying. So that happens here where we grab our... So it's actually nothing wrong with our code, except our code assumed the data would be good, and the data is not good in this one case. Well, this is not that difficult to handle, but we have to be kind of clever. We have to use... we just have to handle the error itself if it comes up. So we're going to try to do this. And if it doesn't work, we're going to catch the exception. What exception? Well, it told us it's a runtime exception. We can even just copy and paste. And then you need to, so this is the type of exception, and then you need to provide a variable for the information to get dumped into, and E is E for error, right? It's just kind of a standard thing to provide. So, whoops, missing a left parenthesis there. So we're going to catch this condition. And then what are we going to do in that case? Well, okay, I said that the population has to be an integer. Let's make it -1. So we'll just assign it to be -1. Oh, it's not defined. Okay, one more step. We will split up this. So first we'll define population. And then in each case we will fill the values. So we'll try to get it as an integer, which will work most of the time. If we get a runtime exception, we're going to kind of assume it's because of this error we just got. And we'll fill in the value with something else like that. So let's see where we're up to in our sketch. If I run it to see the results, we've got our map and we have data overlays. They're totally in the wrong place, however. But I think we can see that the data is being read, and our circles, well, we certainly have circles of different sizes. I really like the way the transparency works to overlay them. So the first thing I want to do is fix the transformation here so the data is on more or less the correct part of the screen. Now this is very much a matter of trial and error because of the approach I'm taking, where I source the map from one place and the data from another. And even at the best of times, it can be difficult making sure that the two align. So I suppose this is what I'm doing is the simplest approach and kind of a bit of a hack approach. So if I try to fix this, here's my location class, here's my constructor, here's where I did the geographic coordinate transformation. I have X and Y values that are based on the width and height of our map. Okay, so I can put some correction factors in here. So hack. correction factors. Let's just call it that. And the first thing I notice is that my y coordinate is really off. So how about I 200 pixels. I'll try 200 pixels, raising it by that amount, and we'll just see what that looks like. Already much better. I think I can assume here that this is the USA, this is China, this is probably supposed to be Iran then because of the outbreak there, and then these are some of the countries in Europe. So already much better. Maybe we need to shift a little bit more. I can shift the X factor by a little bit and make this 220. So this is just a process of trial and error to try and get things more or less lined up. Now, it would certainly help if we had some of the other parts of the program working so that we could see what countries these are supposed to agree with. This looks like it's Brazil, so it should be up further. Actually, you can kind of see that some of these, like, you know, Norway and Sweden might be kind of in the right place, but others certainly aren't. And as you go south, they seem to be off by more. So it's not just a matter of sort of shifting plus or minus the coordinates. It's also a matter of rescaling. So if, for example, I was to, say, rescale by 0.9 on the y-axis, and have a look at that. Now we can kind of see that maybe things are better. They don't need to be shifted up as much now. And so this is just an incremental process. And perhaps to forestall you know, any more time spent on this, I'll just paste in the values that I found to be quite good. Here they are. So China is actually where it should be. There's a couple little dots here for Australia, Brazil, Argentina, Peru. You know, they seem to be, Canada's divided into some of the main provinces here. So Quebec, Ontario, British Columbia. Yeah, this seems to be a lot better. Now, so let's leave it at that and say that's okay. Remembering this is a real hack and not elegant programming by any means. So let's get the interactivity working so that we actually can have some context sensitive information based on where our mouse is pointing. And what I would like to do for this is go back to the main program and our draw loop, and we can see we're drawing the panel. We're rendering our places as dots, and then we have a comment waiting for us here to handle the mouse pointer. So let's do that first thing. So first of all, we want to be sure that our mouse is in the right part of the screen. So mouse X should be within the width of the map. And at the same time, mouse Y should be within the height of the map. And if that's true, our mouse is over the map, which is a good start. So we want to figure out which place is closest to our mouse pointer. So we need some sort of method in locations to determine that. So we have right now our constructor, we have our parser, we have our renderer, and we're also going to need something which returns a location and determines which is the most proximal data point. Is a very common technique that's needed. So here, going back to where we're actually going to use this, we can, location L is the result of calling our proximal function, and that's a method on places because only places knows all of our locations. It's the only object that actually knows all that information. So it's the appropriate place to put this method proximal. Once we have that, we can check that we have a good result. So let's Make sure that's not equal to a null value, because it could be that there's no places close to our mouse pointer. Okay, and then if we have a good one, we will use its hover method to place the information we want on the screen. So this is how we handle our mouse pointer, and this is our draw function complete. It displays the map, it draws our panel, it renders our dots, and it handles a display based on where our mouse is. This is actually all we're going to need here. So how do we figure out which place is closest to our mouse pointer? Well, we're going to want to loop over all the existing locations that are in our array. Whoops, I'm missing an open paren here. Like that. No longer need that there, that's just confusing. So we need to loop over all of these and figure out what's the distance between this data point and our mouse pointer. Well, that's really easy to do because we have a distance function. Each of our locations has its x and y center position stored. Sorry, L dot x, L dot y, and we're comparing that to the coordinate pair that our mouse returns. This gives us some distance. Call it d for distance. And we want to find the most proximal data point. So we want to find the lowest value. And the best way of doing this is to set up a value to compare to. And I'm going to initialize it to the largest possible. Start with largest possible value. So if you remember, we're restricting our tests of the mouse to the area of the map. The map is of a certain width, and that would be the largest possible distance our mouse pointer could be from a data point. So we first give this a huge value, and then each time through this location loop, we will test to see if we have a smaller value. So first of all, is our distance that we've calculated between the center of the red circle and our mouse pointer, is that less than the radius of the circle? This means our mouse is over a red dot. So that's the first thing we want to be sure of, is that we are over a red dot. And secondly, is this a new minima? So is d less than the minima that we've stored so far? Whoops. Put that there. If so, we have a new minima, and we'll store our result, our location. We need to store both things. And I believe that's the entire logic that will work. Okay, I hope. I haven't initialized result. That's kind of silly. Location result equals null. Like that. Result. Return result. All the red has gone away. Okay, so just to repeat the logic then, we're going to set up a float that has the largest possible value, and each time through a loop, we're going to see if we have a smaller value. And once we've completed this loop and checked every location, we will have the smallest possible value. We will know which data point is closest to the mouse pointer. We do that by getting the distance and ensuring that that is less than our previous best value. And at the same time, I've got this extra check to make sure that the distance between the mouse and the center of a red circle still places it within the radius of that circle. So we will know then that we are, mouse is within a red circle, and we have a new shortest distance. 2 checks in one. And if that's true, we need to store that new minima, the distance, and we store the location that we're on in the loop to return. So it could well be that after looping through all the locations, it's determined that our mouse is not on any red dot, in which case the initial value that we put in result null will be returned. And that is why when we're using proximal out here in the main program, I'm very careful to check that we don't have a null value. So double check that we do have a place, and then we will use its hover information. So I think that's pretty well everything we're going to need in our locations, but we haven't yet written hover. So let's do that. What do we want to do when we're hovering over one of our data points? Well, how about we put something useful at the bottom of the screen. Let me just check draw panel where I was positioning stuff. I'm just actually going to copy a bunch of this. So what I do will be sort of in alignment with that. For this is more than we need, but just to make sure I'm using the same stuff. Well, we won't use this, will we? So yeah, so the main thing is text font is going to be set to our normal font. Okay, we do need that. Let's just make sure we have the right color. And then in terms of where we're positioning the text, we had X was equal to 20 and Y was equal to the height plus 40. So we want to be below that. So let's make it the height plus 70. And then what text are we going to write to the screen? Good question. Well, we have a label. Let's put out our label to the screen. This is a text string we have pre-calculated. So that means we actually have to do so here. This is still kind of empty. And I'm not going to go through this line by line. Instead, what I will do is I will just copy the work that I have to save some time. You'll see why in a moment, because I made it quite complex. So let me walk you through this. Actually, I'll get rid of this comma format thing for now, will I? Because we don't have that function available to us. So let me just get rid of it. It doesn't matter that much. Something like this. There we go. Now there's no errors. So what we're going to do is figure out our label. So create a label string that will represent this particular place. So first what I did was I went through the population and I simplified it. So if the population was over 1 million, I've divided by 1 million, and then I've created a string that says it's this many millions. Or if the population is only over 1,000, I've divided by 1,000 and created a string that says it's this many thousands. Just so that I avoid printing large meaningless numbers that are hard to read to the screen. This is just changing the population into a nice readable string. And then in some cases, there is a province, and in other cases, there isn't. So I'm checking if my province string equals the empty string. And if so, I'm just creating a result from my previous text and the country code. But if there is a province, I'm sticking that in here too. And then finally, I'm appending to this the number of cases and deaths information. So I'm just using different techniques that we've already looked at, using string format quite extensively to easily create strings. And the one thing I'll point out is doing this comparison here. I didn't write if province equals quote quote, like an equal sign, so I didn't write this. Whoops, province. And you might wonder why. Equals, sorry. the comparison operator is equals equals. You might wonder why I don't write that, and that's because it won't always work successfully with strings because of how they're stored. Being this literal about comparison to an empty string is not always the best way to do it. Instead, it's recommended in the documentation to use the equals method on the string. And this I have found to work better for these comparisons. I can't exactly tell you why. I just followed the documentation and it worked. So this form label is just a bunch of string functions to give us a nice result. So let's see this in operation. Okay, so this looks the same as it did before. But if I float over here, I get an error. Interesting. Let's see what that is. Null pointer exception. I see why. So form label returns a string, right? It creates a label, but we're not doing anything with it. We should have stuck that in our label. The result needs to go somewhere. Otherwise, label is undefined, and that gives us... Anytime you have a value that's undefined or null when it should have a value, you're going to get this null pointer exception. So even though this was kind of like an uninformative error message, it doesn't say much, I've dealt with this so many times that I know it's because there's a null somewhere. And I just happened to notice instantly, thankfully, that that was why. We went and rendered our label out. This line gave us the error, but label was null, which is bad news. Let's try again. Okay. Whoop. Oh, good. So if I mouse over here, I'm now getting the text down at the bottom, which I can't point to because I need to mouse over here. And it says Brazil population 201.1 million, 1,057 deaths in 19,638 cases. So that's quite nice and informative. If I come up here, somewhere that has a province, it says Canada-Quebec. That could be written better. It could be Quebec, comma, Canada would be a nicer way to write that. Yeah, I'm actually going to change that right now because things like that really irritate me. So this probably makes more sense to be... let me just shift this stuff around a bit. Quebec, comma, and then the country, and then the text. Let's see what that looks like. Let's try Quebec again. That's nicer. Quebec, Canada, population 33.7. So likewise over here, there's some really tiny dots. Shandong, China, likewise formatted. Hubei, China. This is Indonesia. There's a few dots down here. Victoria, New South Wales. Yeah, okay. Some of these dots are kind of small. Yeah, some of these dots are kind of small. Maybe what I'd like to do here is I'm creating this radius scaling. I probably want to institute a minimum here. So I want the maximum, of say 3 pixels and R. So the smallest it could get is 3. Otherwise you're just not even going to see it. That's better. Oh wow, there's a lot more dots now on the screen. A lot more dots. They're still really tiny, but French Polynesia is here. And now I can see places like Queensland and so on, and South Australia. New Caledonia out in the ocean, Fiji, and so on. Yeah, okay, that's a little bit better. Maybe even a little bit more. Maybe 5. So this is, this is the sort of tweaking one has to do to get a nice display. All right, that's much better. That's much better. Now you can clearly see places. So these circles are proportional. The area of the circle is proportional to the number of deaths, and so it quite clearly illustrates the patterns that are going on. Yeah, and that's all there is to it. Now, I haven't implemented zooming because that means refactoring all the data, and our map has only so much resolution in this case, so we wouldn't gain a lot from that. But I think this is a useful visualization. You could certainly perhaps access historical data now to extend this. There's a lot that you could do. You could, instead of representing the absolute mortality rates, perhaps percentage would make sense. So in Brazil, if there's 1,057, it's actually out of a population of 200 million. So that's a pretty small fraction compared to other countries. So maybe it should be based on the fraction as well. That would be kind of cool. And how easy is it to do that? I mean, that's just how we're rendering the circles. So it's in the render method, and we have population information. So we could do that. Let's think about it a different way. Let's do overpopulation. I might need a larger scaling factor now. I'm presuming that I will. Let's just see what this looks like. Okay, no, I need a larger factor. Add another 0. Wow, okay, too big. Okay. That presents a very different picture, doesn't it? When it's by percentage of population, that presents a very different picture, because suddenly we can see that actually in China, because they have so many people, even the main hub of the outbreak is not, really that different from the rest of the country. It also doesn't over-exaggerate this number in the USA, although you can see the USA is still large compared to other places in North, Central, and South America. And in Europe, wow, we really need to be able to zoom in here at this point to see the differences. It really does show that Europe is the hub of the infection currently for various reasons, mostly related to travel patterns and the number of people who do fly in and out of Europe and did from the other parts of the world. So we can learn different things from the data by representing it in different ways. Maybe different colors would be nice, different shades of red, or just different colors altogether. So we could probably represent both types of information here. In other words, the sort of absolute mortality rates at the same time. That could be done with color, it could be done with color. And then this relative mortality rate could be done, as we're doing now, with the size of the circle. We could do both at once. So yeah, experiment with how you're visualizing your data and try and find something that actually, tells a story, something which actually gets useful information across to the reader, or the viewer in this case. So my name is Robin. Thanks so much for your attention, and all the best with your coding challenges.